Hello and welcome to this video about electromagnetism. I decided to make up a special video describing the derivation of the electromagnetic wave equation for my video on circular waveguides, and other waveguides after that, because I've written the wave equation a little bit differently for circular waveguides than I did for rectangular waveguides. So these are the two equations that I wish to derive. I'll just derive the first, because the second is very similar to the first, and may be derived in a very similar way. Here are the standard Maxwell equations that we'll be using to derive the wave equation. We'll make some adjustments to them. Firstly, we'll assume that there's no electric charge around or close by, so that this variable will be set equal to 0. And we'll assume that there aren't any stray electrical conductors close by that can conduct electricity, so that this variable called conductance will be set equal to 0. We'll make this substitution, so as to get this modified version of Maxwell's first equation. Then we'll make this substitution, so as to get this modified version of Maxwell's fourth equation. And so these are Maxwell's modified equations. We'll take the curl of both sides of Maxwell's second equation. We can modify it to be this. The time differential can be better written as a partial derivative here. We can start to manipulate the left-hand side of this equation. We can use this del identity. We can evaluate the divergence of E to be 0 using equation 7. Which will give us this, the Laplacian of E times -1. We can start to manipulate the right-hand side of this equation. We'll make this substitution. I've run out of room, so I'll just rewrite all of the main equations that we want over here. We can take the constants outside of the derivative, and then we can use double dot notation to stand for the second derivative with respect to time. We can put both the right and left-hand sides back together to get this equation. Multiplying both sides by -1 will give us this equation, which is the wave equation for the electric field. The wave equation for the magnetic field H can be derived in a similar way. So that's it for the derivation of the wave equation. This can be used for almost anything and can represent the electromagnetic fields inside a waveguide. So I hope that you found this video helpful and have learnt something from it. Please click like and subscribe if you did. Please write anything that you think is helpful in the comments. I wish you all the best in your quest to study these mathematical subjects. And thanks a lot for watching.